Well, here's part 3. Somehow part 2 got folded into part 1. In any case, I'm sure that some of you are remembering a better way than long division to divide polynomials. Particularly people who grew up in other countries, they learn entirely different methods of dividing polynomials than I know, and for that matter, different methods of dividing integers. Anyway, our synthetic division evaluates one polynomial divided by a linear factor. It has to be a linear factor, and it has to be a linear factor with a leading coefficient of 1. Now, if it's a linear factor but without a leading coefficient of 1, you can always divide out that leading coefficient and get a linear factor with a leading coefficient of 1. In synthetic division, all we have to do is write down coefficients and the constant term, and we're never going to have to subtract. We will only add, and this helps us improve our error ratio. There's a good write-up on it in the book, see page 399. And here's our first example. This is something that we don't really need synthetic division to figure out, but we're going to do it anyway. So, we check the divisor. It's a linear factor with a leading coefficient of 1, so that's cool. And now we write the coefficients and the constant in this fashion. Now, notice here that although the linear factor says x minus 1, it's the thing that is subtracted that goes here. So I have a 1, not a negative 1. And I carry the leading coefficient down here. So what I'm going to do is take that 1, the constant term, and multiply it by the coefficient that I dropped down and put it here. Then I add those two together. Then I do it again. So I multiply the 1 by the 2. I get a 2. I add that to the coefficient that was there in the first place. I get a 0. That's my remainder 0. And the 1 and the 2 make up my quotient. Well, I know that this quotient has to be another linear factor. How do I know that? Because the exponent here was 2 and the exponent here was 1. Okay, so how do I interpret that? It's 1x plus 2 and then a remainder of 0. Another example. Notice a linear factor here, leading coefficient of 1. So, this is what I write down in the first place, and I think you should probably stop the tape here and try it yourself. I'll narrate anyway. 2 times 5 gives me 10. Negative 6 plus 10 gives me 4. 2 times 4 gives me 8. 3 plus 8 gives me 11. 2 times 11 gives me 22. 11 plus 22 makes 33. I'm done. What's this guy? It's what it always is at the end. It's a remainder. My result has to have degree 2 because my original polynomial had degree 3. So here I am. I have from this 5, 4, and 11, 5x squared plus 4x plus 11, and my remainder over the original divisor, or I can write it in the second way. Writing it this way, we'll see what sense that makes in the section on graphing rational functions, which is 2.5. Those two mean the same thing. Now, observe, if we multiply the first quotient here, well, actually both sides of that original equation, by that denominator or divisor, x minus 2, then we're going to wind up with the second equation. And if we divide everything in the second equation by x minus 2, then we're going to get back to the first equation. So they really do mean the same thing. It's just a question of whether you want to look at it as a division or as a multiplication. Here's another alignment issue. Notice the gaps in the numerator here. We don't see anything for x to the 6th or x to the 4th, etc. So when we set up the synthetic division, we need to put a lot of zeros there in their places. We have no x to the 6th, no x to the 4th, no x squared, or just plain x. And also observe, I have x plus 2 in the denominator, which gives me a negative 2 here, because this is x minus negative 2. The degree of the numerator was 7, so I gotta have 8 coefficients here in my synthetic division. I'll let you hit the pause button now so you can try it. Does your result have degree 6? I do hope so. Whoa, look at all that. So, linear factor, therefore I know I just subtract 1 to get the degree of the result, so I know that this is going to be x to the 6th. Then I just scroll along, minus 2x to the 5th, 5x to the 4th, etc. And I have a non-zero remainder in this case. There's my result. These are the coefficients of the result that I copied from the previous page. Okay, what next? While I was doing these problems, my TI-89 was upstairs, so instead I used Wolfram Alpha. I don't know what the price is for iTunes, but on the Google Play Store it's only $3, or at least it was yesterday. And I can't think of any $3 that's going to pack more of a punch for you as a student who has to take math classes than that one. Please try all of the synthetic division problems in this section before going on to the next section.